Welcome to Bot Thoughts by Amtalk Soft. I'm Alex, and Sam is here with me. Today's topic is vector databases, specifically how to choose the right one for production AI applications. Sam, I feel like 2 years ago nobody talked about vector databases, and now they're everywhere. What happened?
The RAG explosion happened. Retrieval augmented generation became the dominant pattern for grounding LLMs in real data, and RAG requires fast similarity search over embeddings. An embedding is just a vector, a list of numbers representing the meaning of a piece of text. Finding which stored embeddings are closest to a query embedding is the core operation of semantic search. Traditional databases like Postgres or MySQL aren't optimized for this. They can do it, Postgres with pgvector can, but purpose-built vector databases do it much faster at scale, with less infrastructure complexity. So vector databases went from a niche academic tool to a core piece of the AI production stack almost overnight.
Let's map out the landscape. What are the main vector databases people are using, and how do they differ?
I'd group them into three categories. First, purpose-built cloud-native. Pinecone is the most widely deployed, it's fully managed, serverless, and incredibly easy to get started. Weaviate and Qdrant are open-source options that also have cloud offerings, more flexible and powerful but more to configure. Chroma is the developer-friendly option you see in most tutorial projects, great for local development but less mature for production. Milvus is the enterprise-grade open-source option with serious scalability credentials. Second, Postgres extensions. pgvector adds vector similarity search directly to Postgres. This is huge because it means you can do semantic search without adding another database to your stack. You already have Postgres, you add an extension. Supabase and Neon both support pgvector out of the box. Third, embedded options. Phaeus from Meta is a library you embed in your application, extremely fast, no network overhead, but you manage everything yourself. LanceDB is a newer embedded option with better developer ergonomics.
pgvector is interesting to me because it's the path of least resistance if you already use Postgres. What are the limitations? When does it stop being good enough?
pgvector works extremely well up to about 10 million vectors with dimension sizes up to around 1,536, which covers OpenAI's text embedding 3 small model perfectly. Its approximate nearest neighbor search uses if-flat or HNSW indexing, and with HNSW you get excellent recall and query times under 50 milliseconds for most workloads. The limitations show at scale. If you have hundreds of millions of vectors, you start hitting memory and storage constraints. pgvector also doesn't natively support multi-tenancy at scale. If you have 10,000 customers and each has their own dataset, managing that within Postgres requires careful schema design. And pure vector search is all you get. pgvector doesn't have the metadata filtering capabilities of Weaviate or Qdrant out of the box. My rule of thumb: use pgvector if you have fewer than 50 million vectors and already use Postgres. Move to a purpose-built solution when you need the scale, the filtering, or the operational flexibility.
Qdrant keeps coming up in conversations with engineering teams building serious production systems. What makes it stand out?
Qdrant is written in Rust, which gives it exceptional performance and memory efficiency. But the feature that makes it genuinely differentiated is its payload filtering. You can filter by arbitrary metadata fields alongside the vector search in a single query, and Qdrant pushes the filter deep into the index so it's fast. For example, find the most semantically similar documents to this query, but only from this customer's dataset where the document type is contract, and the date is after January 2026. In Pinecone, you'd filter after retrieval, which means you retrieve more and throw away more. Qdrant does it during retrieval. It also has native sparse vector support, critical for hybrid search where you combine dense semantic embeddings with sparse BM25 style keyword matching. Hybrid search dramatically improves retrieval quality for technical content where exact keyword matches matter.
Pinecone is the default recommendation in a lot of AI tutorials. Is it actually the best choice for production, or is it just the most marketed?
Pinecone's biggest strength is operational simplicity. You don't manage infrastructure, you don't tune indexes, you don't worry about scaling, it just works. For teams that want to move fast and don't have dedicated infrastructure engineers, Pinecone is genuinely the right choice. The criticism is cost. Pinecone gets expensive at scale, and its pricing model based on pods or serverless RUs can be unpredictable as usage grows. The other criticism is vendor lock-in and less control. You can't self-host Pinecone, you can't tune the underlying index, and you're entirely dependent on their availability. For startups building their first production AI feature, Pinecone is probably still the right default. For companies with serious scale and dedicated infrastructure teams, Qdrant or Weaviate self-hosted on Kubernetes gives much better cost-to-performance and control.
You mentioned hybrid search a moment ago. Can you unpack that? Because I've seen research suggesting pure vector search has real quality limitations.
The limitation of pure dense vector search is that embeddings capture semantic meaning, but can lose specific details. If you're searching for a specific API endpoint name or a version number or a person's name, exact string matches. The embedding might put other relevant content above the exact match because the overall semantic similarity is high. BM25 and TF-IDF are classical keyword search algorithms that handle exact matches perfectly. Hybrid search combines both. Run vector search for semantic relevance, run keyword search for exact matches, then merge the results with a ranking algorithm like reciprocal rank fusion. Research from multiple teams shows hybrid search improves recall by 15 to 30% compared to pure vector search on technical knowledge bases. Qdrant supports this natively. LangChain has an ensemble retriever that combines any two retrievers. For production RAG systems, hybrid search should be your default, not an optimization to add later.
Multi-tenancy. How do you handle multiple customers or datasets in a single vector database deployment without them leaking into each other?
3 strategies, each with different trade-offs. First, namespace or collection per tenant. Each customer gets their own isolated collection or namespace. Cleanest isolation, simplest to reason about, easiest to delete a customer's data. The cost is infrastructure overhead. Each collection has minimum resource requirements. Second, shared collection with metadata filtering. All customers share one collection, but each document has a customer ID in its metadata, and every query filters by that customer ID. Much more efficient for large numbers of small tenants. The risk is filter bugs causing data leakage. A missing filter predicate exposes everyone's data to everyone. Third, hybrid small tenants share a collection. Large, high-security tenants get their own. Pinecone's namespaces support Strategy 1. Qdrant and Weaviate support all 3. My recommendation: start with namespace per tenant, move to shared with filtering when you have more than a few thousand tenants and cost is a concern.
Decision framework. Someone's building a production RAG system today. Walk them through the decision.
Start here. Do you already use Postgres and expect fewer than 50 million vectors? Use pgvector. Don't add a new database to your stack if you don't need to. If you need more scale or you're building from scratch with no existing database, is operational simplicity your top priority? Use Pinecone serverless. Is cost and control your top priority? Use Qdrant self-hosted. Do you need graph relationships alongside vectors? Use Weaviate. Are you prototyping or building a local tool? Use Chroma or LanceDB. And regardless of which you choose, enable hybrid search. Design your metadata schema before you ingest data. Plan for multi-tenancy from day one if you have multiple customers, and benchmark with your actual data. Synthetic benchmarks from database vendors mean almost nothing for your specific workload.
Summary: vector databases are now essential infrastructure for RAG systems. pgvector is the pragmatic choice if you already use Postgres. Qdrant is the best open-source purpose-built option for production. Pinecone wins on operational simplicity. Hybrid search, dense plus sparse, should be your default, and plan your multi-tenancy strategy before you ingest a single document. Sam, what should people go do?
Run the Qdrant Quick Start locally. It takes 15 minutes and shows you exactly how payload filtering and HNSW indexing work in practice. Then read the pgvector documentation on HNSW indexing. Understanding the index trade-offs will help you evaluate any vector database. And benchmark your actual use case with real data before committing to a production choice. The ANN Benchmarks site and benchmarks. Com has real performance data across algorithms. It's a great reference for understanding the speed recall trade-off.
That's Bot Thoughts. New episode every week. Subscribe on YouTube and Spotify so you don't miss it. And if you want to support the show, buy us a coffee at buymecoffee.com/amticsoft. See you next time.